Hello everyone, welcome back to the channel. So today we are going to solve the problem 4 sum from the SDE sheet. So the problem states that you'll be given an array nums which will have n integers and you'll be given an integer target. Now your task is to get 4 elements, that is A, B, C, D, such that A plus B plus C plus D should be equal to target. So in this way, you need to find all the unique quads which give you the sum target. So let's take this example. You have 1, 0, minus 1, 0, minus 2, 2, and the target was given as 0. So you can see we have 3 quads which sum up to give the target 0, like minus 1 plus 0 plus 0 plus 1, which will give you 0. The only condition you need to take care is you need to print all the unique quads. That means none of the quads should be repeated in your answer. So if you are in an interview, the first approach that you're going to tell the interviewer will be to sort the array, and after that you use 3-pointer plus binary search to solve the problem, and you store all the quads that are generated. And after that, what you can do is you can basically use a hash set or something to get all the unique quads, and that will be your answer. So this step is very easy, that is getting the unique quads after you have generated all the quads. But the step that we need to discuss about is this 3-pointer plus the binary search approach. So what you need to do is you need to sort the array. So after sorting, your array will look something like this. After this, you're going to put 3 pointers. One is I over here, the another is J over here, while the other is K over here. Basically 3 nested loops where I starts from 0. Inside that, J will always start from I plus 1, and inside that, K is going to start from J plus 1. That is how you do it. So at the first step, what you say is the value at I plus J plus K will give you 3. So let's assume our target given to us is 9. So what we can say is the remaining element is actually 6. Now you know one thing, since you have sorted the array, the right half of this array is going to be sorted. So what you do is you do a binary search on the right half for 6 and you don't find it. So what I can say is if I use this I, J, K as the first 3 of the quads, I am not going to get the 4th quad because 6 is not there in the array. So at the next step, you move the K to the next 2. Over here, we see that I plus J plus K will give you 4. So the element that you require is actually 5. So you again do a binary search on the right half to check for 5, and you see that 5 is not available in the array. So you again move the K. Again, since it is 2, you will get 4 and 5. So let's move the K to 3. Now when you move the K to 3, what you have is 1 plus 1 plus 3. So that gives you actually 5. So the remaining stuff is actually 4. That is basically target minus 5. So you get remaining stuff as 4. So what you do is you only do a binary search on the right half of the array. Now that is very important that you don't do a binary search on the left half. You only do a binary search on the right half because our nested loops will take care of the left half. So I see that there is 4 available on the right half. So what I can say is 1, 1, 3, 4 can make a quad. So let's push it into the quad. At the next step, K will move over here, then to here, then to here, and then to here. And you're not going to find any more quads. So what happens next? J moves over here and K starts from J plus 1, as you can see. So what we do is we linearly again iterate K on the right and check with the help of binary search, does any quad occur or not. If it does, we actually push it into this data structure. And once we have got all the list of quads in this data structure, we can probably use a hash set or something else to get all the unique quads, and that is what our answer will be. Now what is the time complexity of this approach? Since you are using 3 nested loops, what I can say is that's for sure n cube. And the next thing is you're doing a binary search on the right half of the array. So approximately it's gonna be logarithmic of n. So that is near about n cube logarithmic of n, and you're using an extra space of big O of 1. And if you want to add the sorting to it, it's going to be n cube log n plus n log n. So before we move on to the next approach, I wanted to introduce you to something very big. Now, Unacademy has tied up with CodeChef to launch competitive programming on their platform. In this platform, you'll be learning from different educators. Now, these educators are world's best programmers who have been to ICPC World Finals. Also, they have won medals at IOI, and some of them are also working at the top product-based companies. So currently, Unacademy is hosting a lot of free live classes on their platform, so you can probably try them out. Along with this, they have come up with a subscription plan. Now, in this subscription, you'll be getting interactive sessions. Now, this means they'll be having live classes where you can interact with the educators directly in the live class. Along with that, you'll be having structured courses. Now, they will be having courses for beginners, intermediates, as well as the advanced people. So, there will be live classes throughout the year. You can join any of the course or any of the class that you feel to join, and there will also be recordings of the classes so that you can watch it again if you want to of any given live class. Along with this, they're giving you teaching assistants who will be clearing all your doubts that you'll be facing. So the subscription comes up in 3 variants. So if you want to enroll this and you want to get an additional discount of 10%, you can use the coupon code take you forward. Do check it out. The link will be in the description. So in the next step, the interviewer might not be happy with the solution that you gave to him, and he'll ask you to optimize it, and probably he'll ask you to get rid of that hash set that you're using to get the unique quotes at the end. So the optimal approach will be basically to sort this given array at first, so we will get something like this. And at the next step, we are going to use 2 pointers. That is, we keep one pointer I over here and the other pointer j over here, and we keep the other pointer left over here while the right pointer over here. Now, since we have sorted the array, we are going to use that property to get our optimal solution. Now, what I know is the target is 9. So as of now, the values at I and j will add up to give us 2. So what is the remaining number that we are looking for? We are actually looking for something that is 7. So what we do is, we know that this patch is actually sorted. So we keep a left pointer just next to j, and we keep a right pointer at the end of the array. Now what I know is I need 7. So we are going to use the to sum property. That is basically, I know that 1 plus 4 is 5, which is lesser than 7. Now ask yourself, if you move the right pointer towards the left, will it benefit you? Or if you move the left pointer towards the right, will that benefit you? Now you know one thing, if you move the left pointer to the right, you might get a bigger number on the left, but if you move the right pointer to the left, you might get a smaller number. And you know that your 1 plus 4 is already smaller than 7. So doesn't it make sense to move this left pointer over here? Because we're going to increase that 5 in order to reach to 7. So now our value at left and right will give us 6, which is still lesser than 7. We again need to increase this 6. Now what are we going to do? Now this is a clinical step. Since we are being told that we need to store the unique quotes, what we do is, we know that left is 2 over here. Since we have already checked for this 2 and we did not find an answer, now does it really make sense to check for this 2? No, it doesn't. So what I do is, I just take this left pointer and make it stand over here. Basically, I jump over the duplicates. Now what do I have? I have something as 3 plus 4, which is actually 7. And that's equivalent to our result that we were looking for. So what I can say is, this 1 plus this 1 plus this 3 plus this 4 will actually be my quad, which gives me the target 9. So what I can do is, I can write 1, 1, 3, 4 as my first quad. Now the next step, what you know is, since you have already computed for 3 and you have already computed for 4, so let's avoid the duplicates. So at first, you take the left to here, and at first, you take this right to over here. Why? Because you are eliminating the duplicates, because you don't need to recheck, right? Because you've already checked for 3 and 4. So all the duplicates, you don't need to recheck, because what you need is unique quotes. If you do a recheck, and if you do a recheck for this 3 as well as this 4, you will get a number of quotes, and you don't want that. You want only the unique quotes. So what I do is I jump over the duplicates. So what I see is the left pointer crosses the right pointer. The moment it does, you're gonna stop. So our J was over here. Now do we move our J to here? That is the question we need to ask ourselves. So we already did for 1 comma 1 as the values, right? So do we again need to do this for 1, because we are looking for unique quotes? So does it make more sense to move this J to over here, basically jumping over the duplicates? Yes, it does. So I move the J to this 2 rather than moving over here, because it doesn't really make sense, because we want the unique quotes only. Again, you're going to place the left pointer at 2 and the right pointer at 4. Now what I know is our value at I plus j will give me 1 plus 2, that is 3. So the remaining value that we are looking for is actually 9 minus 3, that is 6. So let's find that out. So what I see is left is over here and the right is over here. So they add up 2 plus 4 to actually give you 6. So we actually got one more quad, that is 1, 2, 2 and 4. At the next step, what do you know is we need to avoid duplicates. So we are going to move this right directly over here. So let's move it. So let's move our left pointer by one step. So our left pointer now reaches over here. Now we see that this left plus this right will give you your remaining 6. So we got one more quad. That is what? 1, 2, 3, 3. At the next step, what do you know is you need to cross over duplicates. So our left will directly move over here and our right will move over here, because we are crossing this 3 and 3 duplicates. So we see that our left and right cross over, and we are not going to get any further solutions for these I and j. So once the left right pointer have given you these quads, you need to move this j. Now again you're going to jump over duplicates. So you reach j over here, and similarly you will do with left pointer over here and right pointer over here, and you will not find any quads for this section. So next time you move your j jumping over these duplicates to over here, and you're again not going to find any quotes. So the next time your j jumps over to the end, because these duplicates are to be avoided. So for this I, the loop of j is completed. So at the next step, what you're going to do is move this I. Now you see that I is also having duplicates. So we got to jump over these duplicates. So we take I over here. Now j will again stand over here. And as we did before, our left stands over here and right stands over here. And again, we are going to look for quads as we did in the previous step. So I hope you got the entire intuition. The intuition is super simple. You're going to move a I loop that basically starts from 0 and goes till n minus 1. And inside that, you're going to move a j loop which actually starts from I plus 1 and goes till n minus 1. And inside that, you're going to use the left and right pointers, because the array is sorted, and you get the quads and you store it in a data structure. So the key point over here is that you jump duplicates. Otherwise, your data structure will contain duplicate quotes, and that is not acceptable to the interviewer. Now, the time complexity of this approach is basically n cube. Now, why is that? Because we know that there are two loops I and j basically nested, so it's a n square over there. Now, you're moving a left pointer as well as a right pointer. So at max, you're going to cover this much. Again, we can call that as a third nested loop, right? Because at max, you're going to cover a patch. So that is the reason 3 nested loops will pile up to give you big O of n cube. And the space complexity will be only big O of 1, because generally we don't count the space complexity that we use to return the answer. So now let's talk about the C++ as well as the Java code. So let's talk about the Java code. In the Java code, we see that we are given a num array as well as we are given the target. And we need to return a list of list which will contain all the unique quotes. So what do you do is we declare an array list of list which will be the resultant array After that, we do a check for the null case as well as the empty array. In that case, we are gonna return the empty array list of list. After that, I sort the array, and we know that we are using two nested loops. One is the I pointer while the other one was the J pointer. Now I get the remaining element, that is target 2. Now what I know is the initial target was target, so I subtract num of J as well as num of I from that. So we will be left off with target 2. Now I keep the front pointer, that is basically the left pointer, at J plus 1, and I keep the right pointer, that is basically the back pointer, at the last index, that is n minus 1. Now what I know is I need to keep on traversing till my front is at the left of back, that is basically meaning they don't cross over. Now I know that both of them sum up to give the 2 sum. Now we already discussed this. If this is lesser than our target 2, so we know that we have to increase the left pointer, that is front plus plus, because we got to increase our summation since it is less. Over here, since it is greater than target 2, we need to decrease our summation. So we are going to do a back minus minus. Now if none of these conditions are satisfied, so what does that mean? That means our 2 sum is actually equal to the target 2. So we got our quad. Now what we do is we create a list and we add all the 4 elements, that is I, J, front, back. And after that we add it to the result. Once we are done with that, we need to remove all the duplicates. Now how can we remove that? We know that we are gonna loop over till front doesn't crosses back, and if the element at the front is equivalent to the element that you got at the initial front, you're gonna just move plus plus front. That is, as long as they're equal, you just keep on moving front. And over here, the same thing, you just move it on the back as long as they're equal. Now why quad dot get 2? Because we see that we have already stored front at the second index and we have stored the back at the third index. That is the sole reason. Once we are done with this, we have a J loop, right? Over there also we have to just move through duplicates. So let's understand this line number 48. Now this is basically to move your J pointer. Now assume you have something like 2, 2, 2, 3 and your J is standing over here. Now you know that J has to move to this 3, but there is a for loop over here which also moves J. So what you need to do is you need to move the J to here, and at the next step the for loop will automatically move J to 3. That is why you move one step back. So that is the reason we are checking for J plus 1 equal to num of J. Similar reason for I, we just check for I plus 1 because we want to stop one step back, because the for loop I plus plus will do our task to move it one step ahead. Once we are done with that, we can return our res, which will have our quotes stored. So now let's discuss the C++ code as well. So we can see that we have to return a vector of vector, and we are given a num vector as well as we are given the target that we need to get. Over here we have declared a res, that is vector of vector, which we have to return, and we do a check. If the vector provided to us is empty, we are going to return an empty quote as the answer. After that we sort the array because that is very important for our algorithm to work. Now we took 2 pointers, one is the I while the other one was the J pointer, so we have taken that. So at the next step we take target 2 as target minus num of J minus num of I, because that is the remaining element that we are looking for, and we keep the left pointer, that is the front, at immediately after J, that is J plus 1, and we keep the right pointer, that is back, immediately at the last index, that is n minus 1. After that we know that we have to loop till they do not cross over. Now the front and back together will give you the sum 2 sum. So what we know is, if this 2 sum is lesser than our target 2, so what does that mean? That our summation value that our 2 sum is giving is still less and we need to increase it. So in order to do that, we need to move the left pointer, that is front, because when you move the left pointer, the value will increase. And if it is greater than target 2, we have to reduce the value. So in order to do that, we have to decrease the right pointer, that is move the right pointer towards the left, that is back minus minus. And if these two conditions are not satisfied, so that means is our 2 sum is equal to target 2, that is the remaining value. So what we do is we go to this else, and inside that we create a vector of quadruple, and we store all the 4 that we're adding up to give our target, and we store it in our res data structure. Once we have done that, what we know is we have to move our front, because we don't want to do a repeated task at the duplicate elements. So what I do is I simply do a check and I move the left pointer. Similarly, I move the right pointer as well, because I don't want to do a repetitive task for all the duplicate elements. Now why quad of 2? The reason is because we have stored the front element at quad of 2, and why quad of 3? Because we have stored the back element at quad of 3. So once we are done with this entire thing and our front pointer crosses over the back, we are gonna take care of the j, because we know that we don't need to work for all the duplicate elements again and again, so we have to cross over. So assume you are standing something like this 2 2 3, and I'm assuming that there is some part of the left array, and now j is standing over here. So what we saw in the algorithm was we were moving our j over here, right? But there is an edge case over here. The edge case is the for loop also moves j. So what you need to do is you just need to move your j over here, and the for loop will automatically move it to 3. So that is why we are doing a check for j plus 1. Similar reason is for I also. You need to cross over the duplicates. So that is the reason you don't move beyond the duplicates. You just move to the last index where the duplicate lies, and after that your for loop I plus plus will do the work. So once you have completed the entire algorithm, you can return the rest. So with this, I wrap up this video.